Hi, I'm Doug Hayhoe, and I've written a series of short video essays and podcasts on science, faith, and other topics. Most of the episodes relate to one of God's two books, nature or scripture. This one is about one of the most famous astronomers who ever lived, Johannes Kepler. His groundbreaking discoveries of how the planets move were the solid basis on which Isaac Newton built his universal law of gravitation. In fact, Kepler was the man who revolutionized astronomy, as a recent biography of him is titled. He was also the first person to integrate modern science and Christianity in his views on nature. The scientific revolution occurred because people now realize that science must be based on careful observations, accurate mathematics, and testable theories. Copernicus, Galileo, and Newton are well-known names of that period, and justifiably so. But there is another person whose work was key, Johannes Kepler. When Newton commented on his discoveries in a letter written in 1675, Newton said, "If I have seen further than others, it is by standing on the shoulders of giants." Those giants were Galileo and Kepler. Here's a portrait of Kepler by an unknown artist. Physics was my first love. In high school, I was introduced to it. In university, I slogged my way through it. Some of my physics instructors were good, some mediocre, and some downright scary. So when it was my turn to teach it, I was ready to try something new. I was fortunate that a new course developed at Harvard University had just come out called the Project Physics course. Instead of emphasizing problems and equations, it focused on historical personalities and their hands-on investigations. It began with Galileo and the study of motion, a common topic in physics courses. But before going on to Newton and force, it looked at Copernicus and Kepler and their discoveries in astronomy. Understanding this step was critical, it emphasized, to fully appreciate Newton's groundbreaking work on force and gravity. Copernicus was the famous Polish astronomer who rejected the geocentric view of the solar system, which had been taught since the days of the Greeks, and adopted the heliocentric view that planets orbit the sun, not Earth. Copernicus still went with the Greek idea of the circle as the perfect form, however. To make circular orbits fit the data, he used a complicated system of epicycles. When Kepler came along, half a century later, he accepted Copernicus's heliocentric model, but had doubts about its complexity. By then, he had access to key astronomical data that Copernicus didn't have. The well-known astronomer Tycho Brahe had made new naked-eye observations of planetary positions that were incredibly accurate. The telescope had not yet been invented. Kepler took this data and plotted it to see how he could make it fit a circular orbit. The orbit of Mars was his nemesis. When he fitted it to a circle, there was always a tiny error in one angle, only 8 minutes of arc. That's a fourth of the moon's diameter. But this was significant for Kepler. He had worked with Tycho Brahe, and he knew that Tycho didn't make mistakes like that. What did Kepler do? On the basis of this one discrepancy, he gave up the idea of using circles to explain the motions of planets, a tradition that was 2,000 years old, and Kepler postulated that the planet Mars's true motion was that of an ellipse. He soon realized that all the planets, as well as comets, travel around the sun in elliptical orbits, not circular ones. He later wrote, "These 8 minutes alone have prepared the way for reshaping the whole of astronomy." I remember as a teacher asking my high school students to plot the observations for Mars's orbit on a large poster board and try to fit a circle onto them. It was fun watching them slowly realize it just wouldn't work. Following in the footsteps of Kepler, they finally rejected the circle and tried fitting them to an ellipse. If they were careful, they found it worked. Kepler's first law, therefore, is that all planets travel in elliptical orbit with the sun at one focus. So here's a diagram showing it. Ellipses have two focuses, but the sun is at one, and planets travel in elliptical orbit around them. Kepler's second law was that planets then sweep out equal areas in equal times. For example, these two areas that are crossed out are equal in area. That's because as the planets are near the sun on the left side, they're going a lot faster. In fact, the planet takes the same time to travel from P1 to P2 on the left as it takes to travel from P3 to P4 on the right, and the shaded areas are equal. Equal areas in equal times. But Kepler wasn't done. He had noticed that planets farther from the Sun move slower. Of course, a planet 5 times farther from the Sun than Earth, like Jupiter, will have an orbit 5 times as big, and therefore take 5 times as long to orbit the Sun if it's moving at the same speed as Earth. Jupiter, however, takes 12 times as long to go around the Sun, 12 years, not 5. So it is moving less than half the speed of Earth through space. Kepler made the amazing deduction, never thought of before, that the Sun is exerting a force on the planets, which gets smaller with distance. Kepler even provided an exact formula describing how the Sun's gravity decreases with distance. The discovery of Kepler's later became the basis of Isaac Newton's universal law of gravitation, the most important law ever formulated. Gravity holds all the planets in place as they orbit the Sun, and each star in place within its galaxy. It's really a universal law. So that's the high point of Kepler's science. Now I want to talk about his faith. The Project Physics course I used in my classroom helps students focus on the personalities and life of the scientists, not just their discoveries. Both Kepler in Germany and Galileo in Italy were Christians. They lived during the Protestant Reformation and Catholic Counter-Reformation. Kepler was Protestant, while Galileo was Catholic. But for both, their faith in Scripture as God's authority was very important. I've commented on Galileo in my episode called God's Two Books. Here I'll only talk about Kepler. Kepler's fascination with God's universe began early. When he was 5, his mother took him outside to see a spectacular comet. And when he was 9, his father showed him an eclipse of the moon. It was no accident then that he later became interested in astronomy. I remember my own fascination with nature when my mother hauled us out of our beds in the middle of the night to see a lunar eclipse. Although Kepler tended to over-promote his own discoveries, as his biographer David Love points out, Kepler never became too proud to give God the glory. When he was writing out his third law, he wrote, "Sun, moon, and planets, glorify him in your ineffable language. And thou, my soul, praise thy Creator. It is by him and in him that all exist." If you're familiar with the New Testament, you'll recognize Colossians 1:17 here. Kepler not only appreciated the order in the universe, he also recognized that in creating us in his image, God gave us the ability to understand his universe. Quote, "The laws of the universe lie within the power of understanding of the human mind. God wanted us to perceive them when he created us in his image in order that we may take part in his own thoughts." It's interesting to contrast this with Einstein's views 3 centuries later. He said, "The most incomprehensible thing about the universe is that it is comprehensible." Einstein was amazed that we humans could actually understand the universe. Kepler wasn't. Many astronomers and other scientists have let their discoveries and fame become the focus of their attention rather than nature itself. Kepler was aware of this danger. He once said, "Astronomers, as priests of God to the book of nature, ought to keep in their minds not the glory of their own intellect, but the glory of God above all else." What a warning. In some ways, Kepler still remained enmeshed in the Pythagorean tradition of the Greeks, for he tried to explain the positions of the 6 known planets by fitting their orbits around the 5 regular solids: tetrahedron, cube, octahedron, dodecahedron, and icosahedron. Nevertheless, Kepler was the first modern astronomer. He broke through the Greek legacy of circles that even Copernicus adhered to and formulated equations for the motions of heavenly bodies that we still use today. Here's my takeaway from Kepler's life. He saw no conflict between science and Scripture. He felt that he could serve God equally well through the study of his works as through that of his word. For although he had originally wanted to be a minister, he came to realize that his calling was to be an astronomer. His hope in his publications, as Gerald Holton of Harvard University points out, was that people's belief in the creation of the world be fortified through this, and that God's inexhaustible wisdom shine forth daily more brightly. Thank you for listening, and please see the written essay on my website for the references and credits.